In this video, we're going to learn the converse of the Pythagorean theorem and how to apply it to problems. If you forget what a converse is, there's a video on all types of conditional statements titled 1.7, previously posted a few months ago, or you'll probably be reminded of what a converse is, or you will be reminded of what a converse is in this video. So, before we get into the converse of the Pythagorean theorem, I want to start off with a problem. We have a baseball infield, and the baseball infield is a square, with each side measuring 90 feet. Using that information, find the distance from home to second base. So if we look at this square, we know that this distance right here is 90, and this distance right here is also 90, and we're looking for the distance from home plate to second base, so how long a catcher would have to throw the ball if someone was stealing second base from first. And since it's a square, we know that angle is 90 degrees. So, since this is a right triangle, we can use the Pythagorean theorem. So this problem, involving a baseball field and the distance from home to second base, could be broken down to a right triangle problem where you have an isosceles right triangle where each leg is 90 and the hypotenuse is the variable that you're looking for. So we would have 90 squared plus 90 squared equals x squared. If I just take my calculator real quick and type in 90 squared plus 90 squared, that will come out to 162 equals x squared, and we can either take the square root of both sides and get a decimal answer. So the square root of 162,000 is 127.7 feet, or 0.3 feet. So, for these distance problems, it's usually better to leave your answer as a decimal because it's easier to interpret a distance as a decimal as opposed to a radical. But this radical could also be simplified, but I'm going to spare you some time and not worry about that right now. So, cancel. Sorry. So why do we do that problem? Well, to lead us to this question, how did we know we can use the Pythagorean theorem? How could we use Pythagorean's theorem? Why did we know we were able to use that in that problem? Well, think to yourself, why? And if you need more time to think, pause the video right now. Well, the reason why is because the triangle in question, which was formed by the first base line, the line from first to second base, and the line from home plate to second base, formed a right triangle. And the Pythagorean theorem says if the triangle is a right triangle, then the lengths of the three sides of the triangle satisfy the Pythagorean equation, a squared plus b squared equals c squared. So that's an example of a conditional statement where you have a hypothesis if the triangle is a right triangle, which if that's true, then you can assume the conclusion that the lengths of the three sides of the triangle satisfy the Pythagorean equation, a squared plus b squared equals c squared. So, what about the converse? Is the converse true? Well, if it is, we can use the Pythagorean theorem to decide if triangles are right, acute, or obtuse. So what is the converse of that statement? Well, remember, converse is just when you switch the hypothesis and the conclusion. So right here is the converse, and all it is the previous theorem with the hypothesis and conclusion switched. So just like the previous theorem said, if a triangle is right, then the lengths of the three sides satisfy the Pythagorean equation. The converse is, if the lengths of the three sides satisfy the Pythagorean equation, then the triangle is a right triangle. Is it true? It is true. And in class, we'll look at why it's true. But for right now, since it's kind of hard to do over a video to prove to you why it's true, you're just going to assume that it's true. And in class, we'll prove and we'll do a hands-on investigation to see why. So it is true. So that means that if the lengths of three sides of a right triangle satisfy the Pythagorean equation, then the triangle is right. But if c squared, so since it's no longer a right triangle, c is just going to be the biggest side. A and b are the two smaller sides. If c squared is bigger than a squared plus b squared, then the triangle is obtuse. If c squared is less than a squared plus b squared, then the triangle is acute. So this set of notes right here that I'm circling in red is what you need to take from this video. And now we're going to apply it. But first, I want to give you a little visual of how to remember when a triangle is right, when it's obtuse, and when it's acute. So, let's say we have a right triangle right here. It's a right triangle with legs A, B, and C. So since it's a right triangle, all is right, no pun intended, with this picture, and a squared plus b squared equals c squared. So we know that if that's true, the triangle is right. Just like if the triangle is right, then that's true, that a squared plus b squared equals c squared. Now, what if I take c squared and I make it bigger? So now I have that a squared plus b squared is smaller than c squared. So c squared is bigger than a squared plus c squared. So I'm going to take this picture and redraw it, but I'm going to make c squared a whole lot bigger. Well, just noticeably bigger. A and b are going to be the same size, and then what happens? This triangle, since c squared got bigger, so imagine a right triangle where you have a hypotenuse, and then a hypotenuse magically grows. What happens to this angle right here? It no longer becomes right, it gets bigger, because the side opposite it, c squared, is getting bigger. So, when c squared is bigger than a squared plus b squared, then the triangle is obtuse. Alright, well, let's look at this other case. What about when c squared is smaller than a squared plus b squared? So now I'm going to take this picture right here and redraw it now, but that c is smaller. So now I have a and b are the same size. So that's c, that's a, that's b. So when c squared is less than a squared plus b squared, since the hypotenuse is getting smaller, what happens to this angle? It gets smaller. So anything smaller than 90-degree angle would be an acute angle. So when a squared plus b squared is greater than c squared, in other words, the hypotenuse squared is smaller than the leg squared, then the triangle is acute. So hopefully that's how you can think about it or visualize the Pythagorean theorem, or the converse of the Pythagorean theorem when you're doing these problems. So, so this first question right here, 4 centimeters, 8 centimeters, and 10 centimeters. Is that a right triangle, an acute triangle, or a obtuse triangle? So to test it out, we're going to take 4 squared plus 8 squared. So I know that 4 is A and B is 8 because C has to be the biggest side. So if you're given 3 sides in a row and you're asked to classify the triangle by its angles, you always take the biggest side and call it C, and the 2 other sides are just A and B. Then you take A squared and B squared, add them together, so you get 16 plus 64, and that'll be 80. And then you compare it to the c squared. So 10 squared is 100. So we have that a squared plus b squared is less than c squared. So this triangle is obtuse. And again, don't try to memorize this. Just think, alright, if a squared plus b squared equals c squared, then that would be right. And if I make c squared, the hypotenuse, bigger, right, here's a right triangle where c squared equals a squared plus b squared. If I make that side bigger, I now have an obtuse triangle. Alright, so visualize the hypotenuse getting bigger, it's obtuse, the hypotenuse getting smaller, it's acute. Alright, let's just try one more problem. We have 5, 10, and 5 root 3. Now, if one of the side lengths has a radical in it and you're not sure which is the biggest side, then one thing you could do is type all of these numbers into a calculator and see what they all are as decimals, because it's easier to compare numbers when they're all in the same they're either all in radical form or all in decimal form. So since we can type 5 root 3 into a calculator and that comes out to 8.66, then we know that 10 is the biggest side. So 10 has to be our C. And also, if you don't have a calculator, another way you could compare it is to say, alright, well 5 root 3, that has to be in between 5 root 4, because 5 root 4 has got to be bigger than 5 root 3, and 5 root 1. Well, 5 root 1 is 1, and 5 root 4, since root 4 is 2, that's going to be 10. So 5 root 3 has to be somewhere in between 5 and 10. Therefore, 10 is the biggest side. Alright? So, but use a calculator if you have it. So first thing we're going to do is take c squared, and that comes out to be 100. And then a squared plus b squared, well, that's going to come out to 5 squared plus 5 root 3 in parentheses squared. Always put it in parentheses because you got to make sure you square the 5 and the root 3 because you're squaring that entire side. So 5 squared is 25. 5 root 3 squared is 25 times 3. So 25 times 3 is 75. 25 plus 75 is 100. So now a squared plus b squared equals 100. so to c squared. So since a squared plus b squared equals c squared, it's going to be a right triangle. That's our final answer. That was an exclamation point. Alright, that is about it. Hopefully that video was helpful. Please email me if you have questions, and have a good one.